Hello, welcome to another episode where we shall be looking at the proposed memorandum for the mathematics paper 2, the November 2025 examinations for the grade 12. 3 hours as usual, 150 marks, the norm. We have 27 pages of an answer book. We have 11 questions in total. People want to kill people now with 11 questions. Okay. There's a special answer book. You may use a calculator. Okay, 2 decimals as always, and then answers only will not guarantee you full marks. So we need to show some workings. Diagrams are not really to scale, and we must apply the correct interpretation. Okay, question number 1, which is the statistics. We have 11 cars of the same model for sale at a car dealership. The age in years for each car and its corresponding selling price in rands is provided. So we know that as cars age, even the value tends to decrease. Okay, that's one thing we know for sure. So the cars that are 2 years old will cost more, 3 years that much, and so on and so forth. So we can see that even with 3 years still, the price can be different depending on the model. Okay, but they're telling us the model is the same, meaning that the condition in which that car is will also impact or influence the price. Then 1.1, they want us to get the regression least square line, okay, the equation. So we know that that equation can be written as y is equal to a plus bx, okay? When I punch all this in the calculator, the a value that I'm getting is quite big. So it's 397, comma, I can say 20 to 2 decimals, ne? Is it a plus or minus? In this case, it's going to be a minus since the price is decreasing. Okay, I have 22988, 32x. So that is what my equation would look like. And then 1.2, can we predict the selling price of a similar car in the car dealership after 5 years? So we know that the year or the age of the car is representing the x, and then the price is the y. So where there is x, we're going to replace it with a 5. So our is going to be 331,397,20 minus 22988, 32 times 5. Okay, so the substitution, the answer I'm getting is a 216. Okay, 216. This is 455,60. And then 1.3, use the correlation coefficient to show whether the prediction made in 1.2 is valid or not. So we know that the correlation coefficient is a negative 0.95. Okay. But now this correlation coefficient are telling us that it is decreasing. Okay. In other words, it is strong and negative. So as the ages increase, the price must decrease. So when you look at 5 years, 5 can be between 4 and 6. And then we are saying we have a 216,455, which is reasonable. Okay, it's just within the price range, just a small nyana difference of a few rands. Okay, so use the correlation coefficient to show that the prediction made in one is valid. So this one is valid. Why? Because the correlation coefficient or the correlation or the relationship is strong and negative. It's negative and strong. Okay, and then 1.4, use the answer in 1.1 to write down the estimated average yearly decrease in the selling price of the 11 cars. So for me to use the equation that I have, this B value here is, I believe, what they want to get, the change in price for each car, okay, per year. So meaning that we're going to have a 22988, 32. Used to write down the estimated average yearly decrease. So the decrease is 22,988, 32. All right, and then question number 2, the cumulative frequency table shows the amount of time that people spent on a particular website on a particular day. Yo. First question, how many people visited the website on that day. So since this is a cumulative frequency, the last cumulative will definitely represent the number of people that are needed. So in that case, I would go with a 70 for that. Okay. Now, how many people spent more than 40 up to 80 minutes on the website? So there's something funny about the intervals of time. They're telling us that from 0 to 20, this is the cumulative, meaning that we can have a frequency column just to distinguish that. Okay, so this is going to be a 16, we agree. But then from 0 to 40, meaning that if we had an interval of 20 less t less or equal to 40, the difference between 16 and 40 would give us what would be there, which is basically a 24, okay? Then from 0 to 60, so this would be a 40 less t less or equal to 60. So from 0 up to this interval, the total must be a 59, sorry, 59. But we already have a 40 for the two. Let's subtract 59 and 40. That will give us a 19. And then we do the same thing. This would be a 60 less t less or equal to 80. 67 minus a 59. That is like 8. Okay, 67 minus 59 gives me 8. That's okay. And then from 80 less or equal to t less or equal to 100. So this is a less. Okay, 70 minus that, it just gives me a 3. So this is one thing that I need to identify first, the frequency. Then how many people spent 40 to 80? Okay, so between 40 to 80, it's just these two groups. So it's 19 plus 8, which becomes a 27. Alternatively, you can subtract these two. Okay, and you get your 67. Wait a minute. No, it's not those two. It's for the 40 and the 67, because that's where the 40 starts from. So 67 minus 40 will also give us a 27. And then they want us to draw a histogram for the provided information. So if I look at the answer book, this histogram is talking about the number of people. Okay, it's not talking about the cumulative. And since we got our frequencies as 16, 24, 19, 8, and 3, now you can see that I've even broken them down into intervals. So this first one, 16, could be somewhere there. Remember, histogram, there are no spaces. Okay, and then 24 for the second one, this is 2025, so slightly below there. Okay, we can connect it to that and then drop it down. And then the next one is a 19, just below 20. Okay, something like that. And then the next one is 8, just below 10, somewhere there. And then we have a 3, which can be somewhere here. There's no problem. So that is our histogram. So no spaces between the bars. If you're shading, then do a uniform shading across. Then next, they're telling us to comment on the skewness. So for us to determine the skewness, you need to look at the tallest bar, which is this. And then how many bars are on the left? It's just 1. How many bars are on the right? They're just 3. So meaning that this data is positively skewed. So you can say it's positively skewed, or someone can say it is skewed to the right. All right, then 2.2. We have 11 players, the basketball team. The coach calculated that on average, each player scored 12 points during a game. Okay, so the mean is 12. Then the points scored by the 8 learners out of the 9 is given in the table below. Okay. How many players' point score was outside of one standard deviation of the mean? So meaning that we need to, first of all, determine the missing score for the 9th person. Then from that, we already have our mean. We shall need to look for the standard deviation. Okay, so What I'm going to do, let me use the formula of the mean and say that I'm going to add up everything. So the sum of the 8 boys plus x divided by 10. Is it 9? No, it's 9, not 10. Okay, so divided by 9. This must give me a 12. So when I add up everything, 11, 14, 19, 20, and all of that, I'm getting a 98. Over 9 should give me a 12. So that's 98 plus x. Then cross multiply. So x plus 98 gives me 108. Move this one that side, meaning that x is a 10. So the last score is a 10. Now, after obtaining the last score as a 10, I have to punch this into my calculator and determine the standard deviation. Okay, so with 11, 14, 19, 20, and all of that, my standard deviation is 5,23. 5,23. Then for me to get the interval of one standard deviation, it's going to be mean minus standard deviation, and then mean plus standard deviation. So it's 12 minus 5,23, and then 12 plus 5,23. What does this give me? 6,77. This gives me 17,23. So how many data pieces are outside of this interval? So below 6,77, I have a 2. Okay. And then above the 17 mark, I have 19. And then I have 20, meaning that how many players' points? So 3 players' points are outside. Okay, so that is how the 5 marks would have been claimed. Okay. And then question number 3. The diagram below, P is -1, 8, Q is -4, -6, R is a 12 and a 2. These are vertices of a triangle that is PQR. And then the angle of inclination that we know is a theta. Okay, then 3.1, they want us to get the length of QR. Okay, so for us to get the length of QR, you have to use the distance formula. That's x minus x1 squared, and then y minus y1 squared. We do our substitution there. X, let's take that to be x1. So it's going to be 12 minus 4, which is a plus 4 squared. And then this is going to be 2 minus, which is going to be a plus 6 squared. So we have a 16 squared plus 8 squared under the square root. Okay, punching that in the calculator, 16 squared plus 8 squared gives me 8 square root of 5. Okay, all of that is 8 square root of 5. Perfect. Then we move on to 3.2. 3.2 is asking us for the gradient of QR. So gradient of QR is basically the change in y over change in x. That's going to be 2 minus 6 over 12 minus 4. That's going to be 8 over 16. The gradient is a half. Okay, and then 3.3, calculate the size of theta. So we know that m is equivalent to the tan of theta. So theta should be the arctan over half. And what does that give me? The arctan over half is a 26,57 degrees. Okay, 3.1, 3.2, and 3.3 answered. All right, then 3.4, they want the equation of QR again. So we have the gradient, that is fine. Okay, so our gradient is a half, meaning that if I use 12 and 2, I'm going to say y minus y1 is equal to m into x minus x1. So it's going to be a y minus 2 is equal to a half into x minus 12, open the brackets. That's going to be a half of x. That's going to be -6 plus 2. So it's a half of x minus 4. That is the equation that the question is looking for. And then 3.5, they want us to get the coordinates of S. All right, so that's 3.4 with the equation. And then 3.5, they say they want us to get the coordinates of S if PQRS is a parallelogram. Now, it's up to you how there are some people that are good at, just getting those points. I don't know how, but they are just talented in getting such points. So if I put the S somewhere there and we connect this and then we connect that, does it really look like a parallelogram? Anyway, they told us that their drawings are not to scale. So why must we stress about ours? Okay, so this is X and Y. So what I did, the long approach, is that for as long as this is a parallelogram, I know that these diagonals are going to meet at the same point, okay? So meaning that the midpoint here is going to be -1 plus 12 is 11 over 2, so 11 over 2. And then 8 and 2 is 10 over 2, which is 5 alone, okay? So 11 over 2 and a 5, and then I can get my X and Y. So that's going to be X minus 4 over 2 is 11 over 2. And then the X becomes a 15. And then I do the same with the Y, that Y minus 6 over 2 should give me a 5, and then Y becomes a 16. Okay, meaning that our S is going to be 15 and 16. Like I said, there are people that are good at, getting those points even without the calculations. Okay, so that's how I would have obtained my values. So 15 and 16. Okay, then 3.6. T is a point on QR such that PT is perpendicular to QR. Okay, let's use a different color for this narrative. So if we have a point T here, okay, and they're telling us that this point is making 90 degrees. They want us to get these coordinates. Now, what do we know about perpendicular lines? Number one, those when we multiply the gradients. Okay, so if I get the gradient of PT multiplied by the gradient of QR, which I already know, I must end up with -1. And then 2, I know that the gradient of TR is going to be the same as the gradient of QR because the points are collinear. Then I'm going to use those two equations and solve whatever I need to solve simultaneously. So this is 3.6. Let's try to go there. Okay, so step number 1, we're saying that if we have our point P, which is -1 and 8, and then T is X and Y. Okay, let's get the gradient there and say that, but we say that gradient of PT multiplied by the gradient of QR should give us -1. So why don't we just substitute once? So it's gonna be a half multiplied by, this is gonna be Y minus 8 over X minus minus is a plus. This must give us a -1, okay? You can multiply both sides by the 2 so that you have Y minus 8 is equivalent to -2 into X plus 1. We can make Y the subject so that it is -2X. This is a -2 plus 8, which is a 6. I'll call that equation 1. And then let me use this point T and the point 12 and 2. And then get the gradient and equate it to a half, okay? Then I'll have my Y minus 2 over X minus 12. This should give us 1 over 2. We can still do the cross multiplication, meaning that twice Y minus 4 is equivalent to X minus 12. This is equation 2. Let's substitute 1 into 2. So it's going to be 2 minus 2X plus 6 is equal to X minus 12. That's minus 4X plus 12 is equal to X minus 12. Move this one that side. Okay. Did we do anything wrong? Then why does it feel like there's something we did wrong? Because why am I having 2y and we said y minus 2, x minus 2 is a half. So 2y minus 4 is x minus 12. Okay. Let me just erase this part. Okay, let's leave it at that. Okay, let me try to make y or x the subject, meaning that x is going to be a 2y plus 8. Okay, and then if I try to do the substitution, there's something I did wrong up here. My points is -1 and 8. So we said y minus 8 over x plus 1 multiplied by a half is -1. Okay, which is very true. And then something seems to be off with either my multiplication or how I'm doing things here. Okay, so let's say I'm going to, remember this is our x. Let me replace this x with the equation I have down here. So that I have 1 over 2 into y minus 8 over, that's going to be 2y plus 8 plus 1. This gives me a -1. Okay. When I multiply both sides by 2, should I do that or I mess it up? I should mess it up once now. Okay, so it's 1 over 2. Why is this question playing me games? So y over 8 over, we know that 8 plus 1 is a 9. So it's going to be a 4y plus 18 is equal to -1. Let's cross multiply. So y minus 8 is going to be a -4y minus 18. Move this one that side, move this one that side. So 5y is a -10, meaning that y is a -2. Okay. Then my x, remember the equation that we just found. Okay, x is going to be 2 times -2 plus 8, which is a 4, meaning that the coordinates of t are 4 and -2. Okay, that is what I'm getting. I don't know why I was getting lost with the first approach. Okay, so that is 3.6. And then 3.7, they want us to get the area of the parallelogram for 3 marks. Now, I don't know why they asked this 90, but I believe there's a shortcut to getting this, because if this is our 90, then clearly there's something that the question intended to, because if this is parallel to that, okay, it's not going to make sense. Let me just use the general formula so that I can get the answer, in as much as it might look a bit long. So it's going to be a half multiplied by the diagonal, which is QS, okay, and then multiplied by the other diagonal, which is PR. Okay, so when I use my distance formula, we already know that, we don't know yet, okay, but we can get it. So my QS that I'm getting or that I'm finding is 13√5. And then my PR is technically square root of 205. And then I'll just multiply that. So that is 13√5 multiplied by square root of 205. And this gives me 208.10 units squared. I don't know, but with this 90, we can use it to also get the answer. Please help us in the comment section how you navigated around with this question, but that's what I'm getting. So probably the answer must also be close to something of the sort. Question number 4. In the diagram, M is PQ is the center of the circle that intersects Okay, the x-axis at A and B, C is a point such that the line drawn from M to C is parallel to the y-axis. Okay, the intersect at D, M intersects the circle at this point, tangents from that and that are equal. The distance is Q minus 1. Okay, so 4.1. 4.1, they want us to get the value of P. So we know that P is the x-intercept, and we're told that E is a -6 and a -1. Isn't that what the question said? Yes. So meaning that P is going to be a -6. And then 4.2, can we show that Q is F4? Okay, so what I did was that by telling us that AM is the same distance as ME, because those are radii of the same circle. Okay. But we already know that the distance MD is just going to be a Q. And then the distance AD is a Q minus 1. That's fine. Then the distance ME, okay, is going to be a Q minus -1, which becomes a Q plus 1. That's one thing that we also need to highlight, that ME is a Q plus 1. So ME is the same as AM. Then let me use my Pythagoras theorem and say that from triangle AMD, we know that AM squared should be the same as AD squared plus MD squared. Our AM is the same as ME, which is a Q plus 1. I'll square that. Our AD, they told us that is a Q minus 1 squared. And then the MD, from there up to there, it's a Q, which is squared. Open up that, so Q squared twice Q plus 1. This is going to be a Q squared minus twice Q plus 1, and then plus another Q squared. Okay, then 1Q squared can cancel the other Q squared. Okay, this can move that side, so that 2Q plus 2Q, I'll have a 4Q. But why am I moving it that side? Let me rather swap everything to the other side so that I have my Q squared to be positive. So this one also is going to cancel this one because of their same sign. So it's Q squared minus 4Q is equal to 0. Take out the Q. So we have Q minus 4 is 0. So either Q is a 0 or Q is a 4. Now Q is a 0 is not applicable here. Okay. Our interest is Q to be a 4. So that is how 4.2 is going to be worked out. And then now if we have the coordinates, okay, -6 and a 4. 4.3, they want us to get the equation of the circle in that format. Okay, so what do we know about this circle? We have the center coordinates. The only thing missing is the distance or the radius. But since this is a vertical line that is parallel to the y-axis, let's just subtract 4 minus -1, meaning that the radius is 5. Okay, come down and tell us x plus 6 squared, and then y minus 4 squared, and then 5 squared gives us a 25. So that is how 4.3 was supposed to be worked out. And then 4.4, if the circle is translated 2 units to the left, determine the minimum distance, the smallest distance between the circle and the y-axis. So if I'm to look at this circle, okay, technically the minimum distance must always make 90 degrees, okay, with whatever line of reference, meaning the distance from this point to this point is what we need, okay? So if the radius is 5 units, but this point here is at -6, meaning that our reading here is at a -1, okay? So if that is the reading where the minimum distance is, if we shift the graph 2 units to the left, that side, meaning that this -1 must also move 2 units that side. and it will be 3 units. So that is just 3 units. Okay, and then they want us to get the coordinates of A and B for 4.5. So A and B, we know that those are the x-intercepts, né? Okay, that is 4.5. Okay. So we know that the equation was x plus 6 squared, and then y minus 4 squared equals 25. So for x-intercept, y must be a 0. So I'll say x plus 6 squared plus 0 minus 4 squared, which is a 16, is equal to 25. Move the 16 that side, x plus 6 squared becomes a 9. Then I'll take square roots. So x plus 6 must give me a plus or minus 3. When I move the 6 that side, meaning that my x values should be a plus or minus 3 minus 6, meaning that the first x value should be a negative 6, or the other x value must be a negative 9. So if that is the case, negative 3 and negative 9, I know that A is the farthest, which is going to be a negative 9 and 0. And then B will be a negative 3 and 0. All right. And then we move on to question 4.6. Determine the equation of the tangent of BC. Now, what we know about BC is a tangent, yes. But tangent and the radius must be perpendicular. So what I need, this is a negative 3 and 0. Okay. I need to find the gradient. I need to find the gradient of this line. So let me jot it this side. Okay, so we say this is a negative 6 and 4. Now this is a negative 3 and 0. So gradient of MB is going to be 4 minus 0 over negative 6 minus 3, which is a 4 over negative 3. So that is the gradient of the radius. Then the gradient of BC, since these two are perpendicular, the product must give us negative 1. So the gradient of BC is just going to be a 3 over 4. Then let's use this point and say y minus 0 is equal to 3 over 4 into x minus 3. So y becomes a 3 over 4x plus a 9 over 4. Okay, so that becomes the equation of interest for that matter. Then they want us to get the coordinates of C. So we know that at C, the x is negative 6. Okay, at this C, the x is a negative 6. Then let's use this equation that we found for BC to find the y value there. So that is going to be, y is going to be 3 over 4 times negative 6 plus 9 over 4. Okay, when I punch this into the calculator, that's negative 18 over 4. Okay, plus 9 over 4, which gives me negative 9 over 4. Meaning that C is basically negative 6 and then negative 9 over 4, or negative 2,25. Okay, that is done. And then now we move on to the next question. Next question is asking us for the angle of ACB. So ACB, this entire angle. Now, how many marks is this question? Should be 4 marks, no? Now, since I know the gradient of this line to be a 3 over 4, I can technically find the angle of inclination here, which will also be the same as this angle. Then I have the coordinates here. I can find the gradient of AC and also find the angle of inclination, which I'll call beta, and then subtract these two to give me that. All right, so we're saying the gradient of BC is a 3 over 4, so meaning that theta is going to be the shift tan of 3 over 4. Okay, shift tan of 3 over 4, I'm getting a 36,87 degrees. Okay, we remember the coordinates of A with negative 9 and 0, and then we have negative 6 and then negative 9 over 4. So let me get the gradient of AC. I'll say 0 minus 9 over 4 divided by negative 9 minus minus, which will be a plus 6. So 9 over 4 over negative 3. Say that is 2,25 divided by negative 3, which gives me negative 3 over 4. Okay, this was a positive 3 over 4. This is a negative 3 over 4. Okay, and then the shift tan of the negative 3 over 4 gives me the negative 36,87, but I need to plus the 180 so that I get the positive part. Okay, nope. We are saying plus 180, which becomes a 143,13 degrees. Okay, so beta is 143, that. Then I need to subtract. Okay, so this is ACB. ACB is going to be a 143,13 minus the 36,87. Okay, minus 36,87, which gives me a 106,26 degrees. Okay, guys, this is what I'm ending up with as my final answer for that last question of 4.8. I don't know what answers that you guys got, but it should be around about 100 degrees. Okay. Then question number 5. Okay, it's given that the tan of 50, okay, the tan of 50 is k. Express each of the following just in terms of k. So step number 1, you need to come up with a sketch. Okay, if that is our 90, if this is our 50, automatically that will be a 40. Since it's the tan opposite, which is k over 1, then this will be the square root of 1 plus k squared. So cos of 40, cos is adjacent over hypotenuse. So it's going to be k over square root of 1 plus k squared. Okay. And then 5.1.2, if I look at this, 2 sine 25 cos 25 is the same as sine 2 into 25 divided by, this looks like a double angle something something. Let me take out the negative 2. What am I left with? A positive 1 minus 2 sine squared of 25. Does that make sense? Yes, makes sense. So by the top, I'll have the sine of 15. And then negative 2. I know that 1 minus 2 sine squared is the same as cos of 2 times 25, which is the cos of 50. Okay, so I'll say this is cos of 15. And then we know that sine 50 over cos 50 gives us a tan 50. So it's going to be a negative a half tan 50. But tan 50 is what? Is a k. So meaning the answer is negative a half k. That's what I end up with. And then next we have the sine of 10. So how does 10 relate with 50? I think I can use the special angles here. That's what I'm looking at. If I use a special angle, this is 5.1.3. So he's saying sine of 10 is the same as the sine of 60 minus a 50. Okay, at least there is something to do with the 50 there. Okay, k1 square root of 1 plus k squared. Okay, this is a 50, that's a 40. Okay, let's open up this using a compound angle. So it's going to be a sine of 60 cos of 50 minus cos of 60 sine of 50. So we know that the sine of 60, okay, sine of 60 is root 3 over 2. And then the cos of 50 is adjacent over hypotenuse. So it's going to be 1 over 1 plus k squared. Minus cos of 50, sorry, cos of 60 is a half. And then the sine is going to be k over root of 1 plus k squared. Okay, then let's simplify that. It's going to be a root 3 over 2 root 1 plus k squared minus a k over 2 root 1 plus k squared. Okay, we're seeing that the denominators are the same, which means our final answer should be a root 3 minus k over 2 root 1 plus k squared. Okay, so that is 5.1.3 for 4 marks. And then 5.2, which is now separate from the k part, they want us to reduce this to a single trig ratio. Okay, now when you look at 540, 540 is just the same as 3 times 180. Okay, and then we know that 180 plus x is in quadrant number 3, and sine is negative in that quadrant. So it's going to be a negative sine x. Okay, and then cos of 90 plus, this is now a complementary angle, it's also going to be a negative sine x divided by, take out the negative sine x. And then whatever is left is just canceling. So this negative and the negative cancels. We are only left with a negative sine x. All right, we've simplified that ratio. And then 5.2.2, hence determine the values of x in this interval for which this entire thing will be real. Now this was reduced, so it will be like square root of negative sine x. Okay, for it to be real, whatever is inside, okay, needs to be greater or equal to 0. Okay, now if I divide both sides by the negative, it simply means that my sine x is going to be less or equal to 0. And then what is the reference angle? The shift sign of 0. Okay, the first value I'll get will be a 0. The next value I'll get will be 180, and then the last value I'll get will be a 360. Okay, now if I have 0, 180, and 360, but I don't want to include, because if I say less or equal to 0, the 0 part is already covered. Then how about these ones? They cannot be equivalent to 180, otherwise everything's going to die out. Even the 0 part, I don't need to put it in because I know that the sign of 0 is going to be 0, which will make this entire thing undefined, okay, if I'm looking at the entire fraction before the simplification. So my values for this case will be 180 is less x is less 360. So that is how I would have worked out that 5.2.2. And then 6.1, they want us to prove that the left-hand side is indeed equal to the right-hand side. Okay, so what do we do? What do we do in this case? So number one, we can start from the left-hand side. Okay. Okay, so this is 6.1. Okay, so let's write down the expression. So we have tan of 180 minus x. We are multiplying it by 1 minus cos squared x, then plus cos squared x. Okay, so where are we starting from? We say the left-hand side. Let's try to reduce this and see where we can see where we are heading, or if we can, there's some light at the end of the tunnel. Okay, so what I'm going to do, let me reduce this. That's going to be negative tan of x. And then I know that 1 minus cos squared. Okay. Should I leave it as a sine squared? Yes, I can just say change it as a sine squared x. And then I'm adding the cos squared of x. Then let me change this into sine over cos. So negative sine x over cos x multiplied by sine squared x plus we have a cos squared x. When I look at my right-hand side, it doesn't seem to be promising, but let's see. I'll say negative sine x multiplied by sine squared x plus I have a cos x multiplied by cos squared x. What do I do here? Do I need to change? I think I have to do that. Okay, meaning that I'm going to, but why did I change this part? Because now that's what is causing me troubles. Okay, over the course of x. Why did I change it? Because now I'm going to be moving in circles. Okay, so no, I'll not erase. I'll just rewrite it because it's going to look otherwise. So if I rewrite it and say negative sine x into 1 minus cos squared x plus this is cos x into 1 minus sine squared x. If I open this up, I have a negative sine x plus this is sine x cos squared x. This is a cos x. Then this is a minus. It's going to be sine squared x cos x. Okay. Are we able to do any bit of grouping since we have 4 terms? Okay, let me combine this and this. Then I'll combine this and that. So I'll say cos of x minus sine of x plus sine x cos squared x minus sine squared x cos x. Okay, on my right-hand side, we have sine minus cos. This is a cos minus sine, which means we can take out a negative, which becomes the sine x minus cos x. What is common here? There's a sine, there's a sine. There's a cos, there's a cos. So I'm going to take out a positive sine x cos x. I'll be left with just a cos x minus a sine x. What do we have? Is it cos minus sine? Oops, it's sine minus cos here. Oh, this is cos minus sine. What did I do wrong? What did I mess up? This is going to be a 1 plus. Okay, which means this I shouldn't have really messed it up, no? But how is the minus gonna, so cos x minus sine x. So this is the same, I take it out. I have cos x minus sine x into 1 plus sine x cos x. Is that what the question is? I have that. And then why is this a minus? Okay, yeah, I get it. So if I take out the negative, remember there is a bottom part of cos x that we forgotten. Okay, this is over cos x and then over cos x. So if we take out the negative is going to come down. Yeah, makes sense. So sine x minus cos x into 1 plus this entire product, sine x cos x over negative cos x. Okay, so that is equal to the right-hand side. Wow. What a marathon of 6 marks. 6.2. Okay. It is given that sine squared of x, cos squared of x, and then a half sine 2x are the first 3 terms of an arithmetic. But these people must know that this is paper 2. Okay, the constant difference of the arithmetic is not a 0. Okay, determine the general solution for x. Okay, so if this is A, this is B, and then that is a C. Okay, what do we notice? If I try to get the difference between the two, I'll have cos squared of x minus sine squared of x should be equivalent to this minus that. So I have sine 2x minus cos squared of x. Okay, we know that cos squared minus sine squared gives us a cos 2 something. Okay, do I need to go that route? Not really. Let me break this down. So it's a cos squared x minus sine squared x is equivalent to 2 sine x cos x. The 2 will cancel with a half. So I'll be left with the sine x cos x minus cos square of x. Then I can move this to that side. Okay, is it gonna make sense? It's going to be 2 cos squared x. And I move this one that side is equivalent to sine x cos x. Why the bracket now? Plus sine squared x. Something like that. But if I'm looking at this ratio nicely, I have cos and sine at the same time. So let's see, if I divide through by cos, will it make sense? Let me divide through by cos squared over cos squared over cos squared. Let's hope I'm not gonna go back to the same thing. Okay, 2, this and this, I'll have a tan x, and then I'll have a tan squared x. Okay, now I have one single ratio, which is user-friendly. So I have tan squared x plus tan x, move the 2 that side is equal to 0. I'll open my brackets and say tan x is gonna be a 2 with a 1. This I'll make a negative, I'll make a positive, okay? Meaning that the first tan x is going to be a 1, or tan x should be a negative 2. Now remember, I'm looking for general solutions. So if I'm to write it down here, is it 6.2? Yes, perfect. So we're saying tan x is a 1, or tan x is a negative 2. So the reference angle, okay, up tan of 1 is going to be a 45. So x is going to be 45 plus 180 times k. K is an element of integers. And then in the third quadrant, where tan is positive also, I have 180 plus 45, which becomes 225. So 225 plus 180 times k. K is an element of integers. When I come this side, the reference angle of the negative, so shift tan of negative 2 gives me a negative 63, 43. But since I want the positive part, I'll just plus with, I can plus with 180, or I can plus it also with a 360. Okay, negative 63,43 plus 180. What is it gonna give me? Minus 63,43, which gives me 116, okay? I mean, that's gonna be in quadrant 2, which is 116,57 plus k times 180. K is an element of integers. And then in the fourth quadrant, it's going to be, we say 360 now. It's going to be a 296, 57 plus k times 180. K is an element of integers. So that is how I would have obtained the general solutions for this question. What are these marks? Aye. Yo, it's like someone gives you, but they don't want to give you. Okay, question number 7. Question number 7. In the diagram, the graph f of x is this. Okay, write down the period. So since f is having a 2 here, okay, meaning that the period is just going to be 180. So 360 over 2, which is 180 degrees. Then they want us to draw tan g of x minus 1. So if I use my calculator, okay, and try to punch in the table approach and all of that. So we're saying mod table. Okay, we're saying it is a tan 2x. We are subtracting a 1. Is that correct? Yes. And then we are starting from negative 35. We are ending at 135, and then the steps are 45. but I'm going to reduce my steps to something like 22,5 so that I can see what exactly is happening. Okay. So at negative 135, it's an asymptote. Okay, we need to indicate that. And then in between here, the answer is negative 2, which is down there. And then at 90, it's a negative 1. And then we're seeing that at the midpoint, oh, there's a 0 somewhere in between here. And then 45 is an asymptote. Okay, let me start by drawing all the asymptotes. Other asymptote is at 45 also. And then the last asymptote is at 135. Okay, so between negative 45, what do I have? I have a negative 2 at this point. And then at 0 is a negative 1. And then I'll have my 0 there. And then after 45, which is negative 2 again, I'll have a 0, and then I'll have that. All right, then I'll just connect this. And then my graph should just tend toward the asymptotes. The graph must tend towards the asymptote. Okay, so that is how our tan graph is going to look like. Okay, so that is for 3 marks. Okay, 7.3. This graph F is translated 45 units to the left to form H. Determine the equation of H in the simplest form. So F is what we're looking at. So if F is cos 2x, where there is x, that's where we're going to move. So it's a cos 2 into x. This is minus 45 because we are moving it to, they say to the left, which means we have to plus. We must plus. Okay, opening up that, we're going to have a cos of 2x plus 90, which is the same as cos of 90 plus 2x. Okay, cos of 90 plus 2x gives us a negative sine x, but this is going to be 2x. So the simplified version of it is a negative sine 2x. And then they want us to write down the range. So regardless of what is happening, it's like it's just being flipped around this graph. Yeah? And the negative sine x, since the highest and lowest is going to still be the same, we're going to say negative 1 less y. Now there has to be an equal sign since it's the range. Okay, and then 7.5, determine the values of x for which this and that will be greater or equal to 0, between 0 and 135. So we know that 1 minus tan x is the same as negative into the tan 2x minus 1, and then the graph of cos 2x, okay? So if this graph is being flipped around, it simply means that our direction is just going to be somewhere here, okay? Same story. It's going to be moving in this sort of direction, in that sort of direction. Now the question is, we need both to be positive, but our points of interest are between 0 and 135. So from this point here. So where do we find both graphs to be above, and where do we find both graphs to be below? So for the above, okay, I'm seeing that this one doesn't make sense. This point is useless. And then at this point, it's also useless. So let me just focus on the below part. So this graph is going to be below at this point here, while this one is also below. And then up until 135. So this point, what is 45 plus 22,5? That is 67. So this half of whatever, this half, which is a 67,5, meaning that between 67 and 135. So I'll come down and say that is 67,5 is less x is, yeah, it's not an asymptote, okay? And then it's going to be less 135. Okay, so that is, oh. Wait a minute. If I look at the original, meaning that it's a 2x minus 1, and then a cos of 2x being less or equal to 0. Okay, that is also possible, that if I look at the red graph, okay, my point is the red graph, and then this other one, where do I find a negative value? So one is above, and then one is below. So you can see that between 0 up to this point. Yeah, that makes sense, because we have 0 less or equal to x less or equal to 22.5. Then where do I find one below and the other is above? So from this point here, which is the 67.5 and then the 135. So I would say 67.5 is less or equal to x, but less than 135. So those are the restrictions that I would go for finally. Okay, question number 8. They're telling us that as a part of the school project, learners are required to design a portable design for a puppet show as shown in the diagram below. The design must fulfill the following. The horizontal is 104, that angle is 52.6, the rectangular block is all of that, and then the ratio is that much. Okay, so what do they want us to do? Can we prove that AB is 18? So if I call this my length, no, that's a lie. If I call this my height and this is my length, okay, they are telling us that if we get the height over the length, 1/2, something like that. So the length is twice of the height, né? But we know that the area is going to be the length times the height, which is 648. Where there is L, let's replace it with a 2h. So it's going to be 2h squared is 648. H squared becomes a 324, and then square root of 324 gives us the 18. Okay, then calculate the length of AC. So if this is 18, then this is a 36. They want us to get the length of AC. Now we know that if this is rectangular, then this is a hypotenuse. Okay, let's use the theorem of Pythagoras, meaning that our AC is going to be the square root of 18 squared plus a 36 squared. Okay, so let's go to the normal mode. Square root of 18 squared plus 36 squared gives me 18 root 5. Okay, so that is 18 square root of 5 units. Okay, then they want us to get the length of KC. So from here up to here, for how many marks? 2 marks. Then what are we going to use? Can we use the sine rule? Because we know that this is a 36. Yeah, I think. So 36 over the sine of 52.6 is equivalent to KC over the sine of 104. I'm looking at the triangle KBC. Okay, then do your cross multiplication. So KC becomes 36 sine 104 over sine of 52.6. Okay, so punching that, I have 36 sine 104, said 104. We are dividing it by the sine of 52.6, which becomes a 43.97. That's what I'm getting. And the next, if AB is the same as BK, AB and BK, so if that is 18, even this one is 18. They want us to get the size of KAC, this angle here. So the only thing that is shorting, we have these two sides. We can find this side so that we use the cosine rule. But for us to get this AK, we can use the theorem of Pythagoras and say that AK is going to be the square root of 18 squared plus 18 squared. Okay, that is 2 square root of 18. Okay, then if I'm looking for the cos of A, this is going to be my K, this is going to be my C. and then this is my A. So I know that cos of A, okay, AC, is going to be the k squared minus the c squared, okay, k squared plus the c squared minus the a squared over twice kc. Doing the substitution, so KAC is going to be the arc cos. Let me do the substitution. So my K was 18 root 5 squared. Okay. Plus, this is 2 root 18 squared. It's 18 root 2 squared. Oh Lord, so which means this is wrong because it is 18 squared plus 18 squared, which is 18 root 2. Sorry about that. Okay, 18 root 2, this is squared, minus the A, which is a 40, we got it as a 43.97 squared. And then we are dividing this by the 2 times the 18 root 5 multiplied by the 18 square root of 2. Okay, when I punch this into my calculator, I'm getting a funny angle, which is 80.60. Okay, so you can verify with me, but that's what I'm getting. So we said 18 root of 5. We square that plus the 18 square root of 2. And then we square that minus 43.97 squared over 2 times 18 square root of 5 times 18 square root of 2. Yeah, 80.60. All right, question number 9. Okay, in the diagram below is the center. KTP lies on the circle and blah, 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 blah. Can we prove the angle at the center? Step number 1, you need to construct the line KO. Okay, and then label this one, label that 2. Now, what we're seeing is that this is a radius, this is a radius, that's also a radius. What does that mean? If I break down this to be a 1, this to be a 2, so let K be divided into a K1 and K2. We said construct the line KO. Okay, then let me get O1. We know that O1 is an exterior angle of this small triangle. Okay, but before I even go to the O1, I know that K1 is going to be the same as T. Angles that are opposite equal sides, okay? Meaning that O1 is going to be twice K1. And then I'll do the same and say that K2 is the same as P. Angles that are opposite equal sides, meaning that our O2, this one, is going to be twice K2 because of the exterior angle of a triangle. Then come down and say O1 plus O2 should be the same as twice K1 plus twice K2. But O1 and O2 is the same as TOP. Is 2, let's take out the 2, is K1 plus K2, which we said it's a K, which is twice TKP. Okay, so that is how we prove that for the 5 marks. And then 9.2, in the diagram below, O is the center of the circle, half is the diameter, and then MF is a tangent, and then this angle is a 32. What's the size of O2? So this is creating the angle, but this is also creating the 32. So this must be a 64. So angle at the center is twice angle at the circumference. Okay, I think that is how I would have gone about with that. And then they want us to get M. Before we get M, tell us that OFM is a 90 reason, turn perpendicular to the radius or turn perpendicular to the diameter. And then if that's a 90, mean that M is going to be a 90 minus 64, which becomes a 26. Okay, so that's how I would have approached question 9 first. Question number 10, in the diagram, PQRS is a cyclic quad. T, okay, is a point on a circle such that QT is perpendicular to SR, perfect. And then PTST are drawn, Q2 is a 35, beautiful. Then R is the same as S1. This angle here is the same as this angle here. Okay, then 10.1, calculate with reasons QTS. QTS, this entire angle is what they need. Does that make sense? It has to. Doesn't have a choice. Okay, so one thing I know is that my QTS is gonna be the same as this angle here, R, because of angles in the same what? Segment. So if I can find R, then I'm good to go. So I know that R plus the 35 should give us the 90. This and this should be equivalent to this 90. Why? The exterior angle of the triangle QVR. And then what is 90 minus a 35? It becomes a 55. So if that is 55, they're telling us that this is also a 55. And the question told us that that was a 55. Okay, so that is how we would have obtained that. Then 2. Oh, somebody can start by working this out. And then you tell us angles in the same what? Angles in the same segment. So therefore, QTS is a 55, angles the same segment. So angles subtended by the same arc. All right, then prove that PQ is parallel. Now, whenever we are proving parallel lines, look for the cointerior, alternate, and corresponding. So if this PQ is parallel to SR, if we have a 90, then we just need to prove that this angle here is also, can that be a 90? Yes, we need to prove that it's a 90. If we can do that, then we use the cointerior approach. Okay, that's just the hints up or heads up. So step number 1, I'm going to say that my S2 is a 35 because angles in the same segment. Okay, meaning that PST is going to be a 35 and that which is a 90. But we know that Q1 is also a 90 because of this cyclic code PQST that they told us. If that's a 90, automatically that would be a 90. So opposite angles of a cyclic quad. Okay, now since this is a 90 and then that is also a 90, just the Q1, therefore PQ must be parallel to SR because of the converse of the co-interior angles, converse of the co-interior angles. So we know that this and that must give us the 180. All right, then 10.3, can we prove that PT is a diameter for 2 marks? Now we've just proved that this is a 90. Okay, and then previously we said that this was also 90. So for as long as that is a 90, then definitely. So we're going to say that PST is a 90, and therefore PT is a diameter. A reason, the converse of angle in a semicircle. Okay, so you can do with PST or we can do with even the Q1. That's enough. All right, so that is question number 10. Question 11. Question number 11. So because of time, I'm going to just rush through this question 11 very fast. Okay, so in the diagram, ABC is drawn, BA is produced to E. So F and D are points, okay, such that AD is parallel to EF, and then AC and EF intersect here, that we have these ratios. CF is a 2, you can say 2x, and then FB is going to be a 5, okay. And then CG is a 3, GA is a 2, okay, just the ratios. And then they want us to determine with reasons the values or the value of FD. Where is FD? This is FD. Let me use a red. Okay, this is FD over CF, this one. Now, what I'm seeing is that if I look at these triangles CAD, okay, if I look at FD over CF, it's going to be the same as AG over GC, and that's going to be 2 over 3. So reason is the proportionality theorem because AD is par to EF. And the next, they want us to give the value of BA. Okay, BA, this one over the EA, this part. Now, since we've said that FD is being represented by a 2, because we are saying that FD is being represented by 2 units, okay, that's what we are having here. Meaning that out of the 5, this BD is going to be a 3, okay? And then before we even go further, let's just start by writing the ratios down. Since they want BA over EA, which is going to be the same as BD over DF. Okay. What do they want? You just need to flip this around. So the reason is going to be still the proportionality theorem. AD is parallel to EF. Okay, then having said that, we know that our BD from here up to here, we said is 2 units. Sorry, FD is 2, which means this BD is going to be a 3 units. Okay, so BD is a 3 over 2. So that is how I would have obtained that. And then next, talking about the area. Okay, the area of G is something. Was there an error with this paper? No error. No. They said area of triangle GFC. GFC, which is the triangle, and then the area of FDA. Wait, GFDA, which is this trapezium. Okay, area of that, and then the area of that. Okay, so what's going to happen is I can create the same height. Okay, meaning that for me to get the area of GFDA, it's as good as me getting the area of CDA divided by the area, not divide, minus the area of GCF. Okay, for me to get the area there. So area of GFC, we are saying a half multiplied by CF multiplied by FG over, it's going to be a half CD multiplied by GF minus a half CF multiplied by FG. Okay, so I take out what is common, which is the FG or GF, means that a half CF multiplied by FG over, this is going to be a half FG into a CD minus a CF. So this FG cancels the FG, their half cancels their half, and then I'll be left with a CF over a CD minus a CF. So what is our CF? CF we said was 2 units. Okay. Over the CD, from here up to here, if that was a 2 and the 2, that becomes 4 units minus the CF, which is a 2. So which is 2 over 2, which is the 1. Guys, I don't know, but this doesn't seem okay with what I need. But just that's how I would have gone about it. Question 11.2. 11.2. In the diagram, W's VZR is a cyclic squad. Okay. And then there's a tangent that is produced to touch the circle at S, VW produced to E, point to QZ, and all of that. We have parallel lines and stuff. Then can we prove that PR is the same as that? So what we need to look at is basically the triangles that are similar. So we know that this triangle, okay, triangle WRE is similar to PRQ. So what are we going to do? 11.2.1, I'll say that if I have my PR, okay, divided by my PW should be the same as someone that gets the QR divided by the QE. Reason, we're saying similar triangles. And then we want PR, which is going to be PW multiplied by QR over QE. And then prove with reasons. Okay, they're telling us if PQZ, okay, is similar to RQZ, can we prove that this is that? So 11.2.2. So meaning that if the two triangles are similar, we shall have PQ over RQ is the same as QZ over PQ. So this becomes, when you do your cross multiplication, PQ squared is equal to RQ multiplied by QZ. Why am I having QQ? We said QZ. Okay. Then 11.2.3, they want us to prove that those triangles are similar. So 11.2.3, what do we notice? QSZ being the same as, or being similar to that. So we know that S1 is going to be the same as R2. That is a turn code. We know that Q2 is the same as Q2, which is common. And then Z1 must be the same as QSR, the remaining angle of a triangle. So therefore, the triangles are similar because of the angles. And then 11.2.4, can we prove that PQ is the same as QS? Now, if we look at the triangles that we've just proved similarity, okay, we can say that if we get the QS, okay, QS, we are dividing it by the QR, should give us the same value as someone that uses the QZ over the QS. Since we are looking for QS, QS squared is the same as QR multiplied by QZ. But remember, in the previous question, we say that PQ squared is the same as RQ and QZ. RQ and QZ. So meaning that P squared or PQ squared is equal to QS squared. Okay, and then we have our PQ being equal to QS, just as the question wanted it. All right, guys, so that brings us to the end of the paper. And I would say the paper was just average, okay? Because there's a whole lot of technical aspects, but yeah, I wish you guys all the best. Let's keep our fingers crossed, okay? Bye-bye for now.